Hello everyone, welcome to Grade 12 Physics AP, Mastering Kinematics in Minutes. In this video, I'm going to go over to the solution for the quiz in our Physics Mastering Kinematics app. Now, if you don't know what I'm talking about, please look at our YouTube video description, and you would see the link in where you could download our map app for your mobile device. Inside there would be the quiz in which we are going to go over. Solution to question 1. So we know that our train goes from rest to 50 meters per second. So you know that the initial velocity would be 0 and our final velocity would be 50 meters per second. Now we don't know what the time is, and also we don't know what the acceleration is. That's what we need to find out, by the way. Now we know that it takes the train 100 meters to achieve that final velocity. So how are we going to do this? Well, we got 3 variables. We need to find A, or the acceleration of the train. So we would use the formula Vf squared equals V0 squared plus 2A delta x. And then we would see that it's 2500 equals 200 times acceleration, or acceleration equals to 12.5 meters per second square. So, solution to question 2. Now this is a hard problem because that we are not finding how long does it take to reach back the ground, the ocean level for the dolphin, but it's 0.1 meters above the ocean floor. So how are we going to do this? There are more than one way, but I'm going to show you just one way on how to solve it, which I think it's the most logical sense. And this is to split up the problem in 2 sections. The first segment is in which the dolphin jumps up from the ocean floor to the highest point in which it can reach. And then the second segment would be from the highest point back to just 0.1 meters from the ocean. So the first segment, we would have the initial velocity as 8. And then the final velocity is 0. Acceleration is minus 10 because of gravity. And the displacement is what we're trying to find. Now for the second segment, we know that the initial velocity will be 0. We don't know what the final velocity is. We don't know what the time is. We got the acceleration, which is minus 10. And we have not a clue of what delta x is. So we only got 2 variables for the second segment, and we got 3 variables for the first segment. So what we're going to do is we're going to find the time for the first segment, and then we're going to also find the displacement for this for the first segment. So what were we going to use for the displacement for? Well, we know that the displacement for the first segment is just 0.1 more than the second segment, because that you said it's from the highest is like just 0.1 from the ocean floor, and the first segment is from the ocean floor to the highest point. So we can find the t for first segment and the delta x for the first segment in order to find the delta x for the second segment to find the t for the second segment. And the duration, when we add the two times together, the first and the second segment, we will find the answer, which is t. Sounds confusing, right? So let's get started. So first, we will find the t for the first segment, which is, we use the formula Vf equals to V0 plus At. So we substitute all the numbers in. We find that t equals to 0.8 seconds. Hold on to that. Now we need to find the delta x, which we use the formula Vs squared equals to V0 squared plus 2a delta x to find delta x. So now, delta x, we could find that it is 3.2 meters. So let's go to the second segment now. Second segment, we know that delta x would be just 0.1 meters short from the delta x from the first segment. So delta x for here is 3.1 meters. Now, how will we find t? Well, we know that we could use the delta x equals to V0t plus half at squared formula. We substitute all the values in because the delta x is heading downwards, so it's going to be minus 3.1 equals to, well, because your initial velocity will be 0, since you go from the top and the dolphin doesn't have any velocity going upwards anymore, we have 0 times t, which is 0, plus half times minus 10, because going downwards, times t squared. So if we just massage those numbers a bit, we would get t equals to 0.79 seconds. So if we were to add those two together, we would have t equals to 1.59 seconds. Solution to question 3. So as you can see, this is a cannonball question, so pretty sure it's going to be a projectile problem. Now for projectile problems, remember that we would need to split all of these variables into horizontal and vertical portions. And we see that the initial velocity for the cannon is 5 meters per second at an angle of 10 degrees above the horizontal, and we need to find the final velocity. So as you can see here, here's the table for all the values that are being found from just a very short sentence for the problem. You only have basically two numbers in the question, but you could actually fill up a lot. So first of all, we find the initial velocity for both horizontal and vertical. That's because we can times 5 meters per second by cosine 10 to find horizontal, and 5 times sine 10 to find the vertical of the initial velocity. We don't know the final velocity. That's what we need to find out. And then we need to find out, we also don't know the time. However, we do know is the acceleration for both directions, because all horizontal acceleration is 0, and the only acceleration for vertical is the gravity, and it's going downwards, so it's minus 10. Now for the displacement, horizontal we don't know, but we know the vertical for horizontal displacement, because from ground level to ground level, guess what? Vertical would be 0. So how should we go about with this problem? Well, we could go find time first, and we could use delta x equals to v0t plus half at squared. So if we find the time, we could see that time equals to 0.174 seconds. Now, if we then use the formula Vf equals to V0 plus At, actually you don't really need to. You could actually just go straight with another formula, but this is another way to do it. It's a two-step process, but it's easier on the math. And if you do that, you would see Vf is going to be 2.61 meters per second. Now, don't stop there. The vertical velocity is 2.61, but that's not the answer, because we need to find the final velocity, the overall final velocity, which is at an angle of 10 degrees. So we divide this by 10, and we would find that the final velocity would be 15.35 meters per second. Because in the beginning, if you would see that it's the initial velocity times sine 10. So to get back the final one, you just need to divide by the same value, which is sine 10, to get the final. And thank you for listening to our video. This concludes the lecture. If you are interested in more studying materials, please download our physics app and other AP course study apps. This can be found in the links in our video description through YouTube. Also, if you want to keep up to date with our latest videos for studying purposes, please subscribe to our YouTube channel, and please share our videos via Twitter and Facebook. Thank you.